an unprecedented opportunity for us to look, step back and say, how do we apply the machine learning algorithms, machine intelligence, which is possible today because of the compute power, because of the storage. I did an AI algorithm that I published a paper in 1995 on case-based reasoning, but we could not do further than that because compute was so hard. To compute a 9K by 6K image took us 3 days to run an eigenvalue, to compute an eigenvalue on that particular image. So you can imagine where we came up. I have thousands of 9K by 6K images in my pocket today, in my phone.
I know.
So this is the change which is making the third generation of AI is possible. And with that, let's look at so when people say traditional IT ops, is it possible to really transform? Yes, it is possible. The traditional IT has to look at how to leverage the data that they're getting in a holistic way, not in a siloed way, like network, database, application, storage and security. You have to look data holistically, the flow of data, how it is flowing in your business operation, how it is meeting the need of business. When you look at a data-driven organization, when you start thinking, how does the data flow? The data decides the process governance, not the process decides the data. And then you basically, when you are looking at ephemeral nature of devices, resources, applications, everything serverless which is going to increase the complexity, that's when you look at future ops or digital ops or whatever name you call it. But that's how we look at it. And we say, okay, how do we then, if you want to be a data-driven organization, what does it mean? Why the context of data is so critical? So let's look at how do you do that. So previous speaker just showed you so many use cases, and this is in the context of AI ops, because Gartner coined the term in 2016 as algorithmic operation, which means you write algorithms to automate a set of processes. Now here, we are talking about artificial intelligence because they changed the name again in 2017 and made it artificial intelligence. So those of you who know, machine has been doing physical work for us for many, many years, since Industrial Revolution. But now we are asking the machines to do thinking work. So thinking work that we are applying, automation is the process of applying a set of algorithms and machine intelligence in order to solve a set of mundane tasks. If you look at a set of tasks here, so that you can deploy your strategic resources, your core resources, your valuable resources in doing skill work of interpreting data, analyzing data that AI ML cannot do today. Yes, at one point AI ML could magically solve the problem, but we don't believe that the magic is at there. We believe that you still need to work through the data, understand your process, and you have to think big, but you have to take small incremental step. And if you look at each of these use cases, we have been doing alert correlation, deduplication for last, 25 years. But alert correlation, noise, people still talking about how do I reduce noise? How do I not have 20 people monitoring the screen 24/7, all the time to see if there is a breach, if there is a data volume, if there is some change happening in their environment. And how do we correlate to get signal out of it? How do we do intelligent alerting and intelligent incident so that we can assign it to the right people? Today, people spend 65% of their time just identifying whose problem it is. So you will see war room, you have heard of war room, you have heard situation room, you've heard escalation room. That happens, you bring all your high-paid resources there in order to troubleshoot and find out a P1 issue that is costing you millions of dollars, every minute or every hour it is down. So we look at all these use cases and we believe each use case has a contextual information that it needs in order to provide value. But eventually you can bring all of them together to really get to your root cause analysis, and automation that you are looking in order to solve the problem, the complex environment that you are looking, where half of your resources are working workload and on-prem, half is in the cloud, and it could be multi-cloud. You might be running something in Azure or something in AWS. So when we look at that, we look at, say, okay, why the data is important. If you look at the raw data that comes in from different sources, has a lot of missing links. It could be coming from different formats. Even though JSON, in the morning we heard the JSON has been a standard now for the data exchange, but still the data that are coming could have a different meaning, even if they're coming from all different kind of monitoring tools. You have point monitoring tools. Inaccurate and fragmented data could lead into very inexpensive downstream analysis because you will spend expensive data science, data engineer work to find out why the data is not working after you have gone through all the application. So it is very important to start at the source, because if you start at the destination, it's too late. If the data is not right, you get into 3 problems. First problem, contextual blindness. We call it contextual blindness because you are looking at a problem in isolation. A network monitoring tool has thrown some problem, but you have no context why it has come, why is the problem? Is there a breach? Is there a suddenly high traffic in the network? Is an application congestion has happened? You don't know. Second, gap stitching. What does gap stitching mean? It means things you cannot model, most probably you cannot measure, you cannot predict, you cannot interpret, you cannot analyze. For example, your infra monitoring tool says, we have a CPU that ran out of threshold. What does it mean? Yes, it is running beyond 90%. Does it impacting application? Which application is it impacting? What kind of users are getting impacted? Which site the users are getting impacted? We don't know, right? Because we live in a connected world. We expect reliable, secure, reliable connectivity 24/7. And any outage, any degradation in customer experience, or any interruption means a brand reputation for that organization. How many of you experienced recent Google outage that happened over the weekend 2 weeks ago, right? So think about it. What did Google has to do in order to solve? How many millions of dollars or what number of resources they deployed in order to solve that problem? So you can see what kind of brand reputation, what kind of a revenue loss, what kind of a customer experience you get, because we live in always connected 24/7 world. So it is very important for you to understand the data that you are bringing in, because at some time, human cognitions cannot be just replaced without understanding, because you are trying to do a few things that can be done, but you are also over time trying to have the machine perform better in a predictable, repeatable way. That's when you bring predictive IT in your real operation. So let's look at, and we'll go through a few examples how we are looking to solve so that they're very concrete and we are not talking kind of pie in the sky, right? So let's walk through a few of them. So let's talk about some of the things that you have been looking at. As I said, we are moving from hindsight to insight. And then people start looking at foresight, because then you want to prove yourself, your business, a technology proof, right? How do you make your business technology proof so that you are not changing? How do you be proactive? How do you be future proof, looking at your customer, understanding everything? I recently heard that some of the retailers are doing real-time video surveillance. So you walk in a store, they have a discount, and they kind of have your image. Somehow they kind of match you because you are a regular shopper in that store, and they could send a text or a message to your phone showing the discount that you may not be looking that part of the store. So that means, think about the speed and the computation they are doing. So that is completely different. Maybe it's not an AIOps issue. It is a customer relationship, a customer engagement issue that retailers are trying to solve through the machine intelligence, through facial recognition, through location. So when we look at it, because all about context means who, where, when. In the need of resources, you can say usage, which user, what location, what latency. So if you look at, there are 3 areas that we are looking to solve the problem and bringing actionable insight. One is recognizing redundant alerts, what it means, how your resources are connected, whether they're ephemeral in nature, whether they are static in nature, whether running on the cloud as a PaaS service, or whether you are running on-prem. Second, how do you become preventive and proactive in looking at the usage of a resource? And the third, how do you make use of your patterns, data, model, in order to make your system learn and then take actions. So we will walk through each of these use cases and let's see how. So 5 use cases. So if you look at today, on a Sunday night, somebody updated something to a switch, maybe a firmware update, it was a minor patch update that was done on a switch. And suddenly, everything is escalating there because you have a bunch of VMs running on a ESX server, and there is a switch B and there is a switch A. And suddenly there's a flood of escalations or flood of alerts that is coming in your system, and then there has to be some triaging done in order to find out what caused the problem. There definitely is change. We believe, as in machine learning, artificial intelligence that we are talking about, statistical model, computational model, but graph algorithms will play a key role. And I think Muthu just talked about, right? How does the graph algorithm with temporal algorithms like timing? So when this particular thing we are looking at, when a relationship is built between the consumer and producer of your resources, so there is a dependency mapping, the switch is a producer, server is a consumer, you immediately, the algorithm is deciding, hey, hold on, all these alerts have no meaning. The alert only that means is the alert that is related to switch A, and everything else you can ignore, and we are tying all those alerts to switch A for you to, cascading alerts because they all happen because of a connected regions, and they're happening at a given point in time. Let's look at the second use case, which is chain of alerts with the same root cause. So for example, if you have a server, something changed in the server went down, but you have a bunch of applications. You have an app server, Tomcat, you have MySQL, maybe you have some other, your own e-commerce application which is leveraging app server and MySQL and using, and people are complaining we can't log into the system, or the page is not opening up, or you're getting some kind of an error. Basically, the system should automatically take some action. So here we are showing the use case, but there should be remediation as well. If the server is down, can the server be rebooted? Can the server be restarted and solve the problem? So this is the chain of alert. How do you solve the problem? So the way you look at a discrete use case, apply the discrete set of data, apply the set of algorithms that is best suited for that, and try to solve the problem where you can eliminate the need of human intervention and let the machine take and do the right job for you. Now, chain of alerts, the microservices. Some of you might be implementing microservices. So you have an authorization service and you have authentication service, and then a bunch of application service. Maybe authentication service is fine, while authorization service is giving some kind of an error. How do you connect? They could be running within the same cluster. They could be running within different clusters and different Kubernetes clusters. How are you communicating between the two clusters to find out the dependency and making sure that you are ahead before your end users or customers saying something is not working? So how do you be the first one to know what the problem is so that you can take action before somebody else is telling you that it is not working? In your NOC, maybe the system is saying it is slow, but the system is about to go down, right? Last, this is like you trip on a wire, you just unplug something, or you applied network configuration change, which could be very risky at some point, and maybe everything, all your SNMP agent and the network configuration stopped working. So here, the system may not know what the root cause is, but it knows all these alerts that is getting generated are because of a common cause, but the system may not be smart enough at this point in time, intelligent enough to tell you exactly the root cause, but it's saying, hey, look, all these things are related to same common issue. Let's go troubleshoot that common issue first. We talked about dynamic threshold, forecast, and anomaly. So this is mostly if you're looking at your disk usage, your or some connections that DB connections you have opened, and you look at a certain point when the scale where you want to hit. Like for example, you have a hard disk, you want to know when it is 70%, I want to get a warning. When it is 80%, I want to get critical, and you want to get the alerts, and you know how to take action. You want to auto-scale the storage, maybe in S3. You want to auto-scale in your own private cloud. But you want to manage that so that you don't wake up at 2 a.m. in the morning to know what is happening. Anomaly detection. So something changed, and the change is not flapping. It is persistent. It is consistent for a certain period of time. that means it didn't flap up and down and went away. That means you need to take some action because something is not going to work properly in minutes or hours, right? For example, at 2 a.m., you can auto-suppress as well this flapping or this auto anomaly that you have. At 2 a.m. on Saturday morning, there's a big backup job runs that basically violates every threshold that you are measuring. But at 3 o'clock it goes away. The machine could be smart enough to learn and not page anybody because it has violated all metrics. It will automatically wait till 3, and if it goes away, it's fine. But if it continues till 3:30, that has not happened the pattern, most probably it should notify and let you take some action. Using the context to generate incident. This is where it comes in, all of you might be using some form of ITSM in order to manage your tickets, your incident, problem, change, service request, your release. Categorization, when I talk to some of the big Fortune 500 companies that, I talk to them, they always say, we don't know where the incident is because, as you know, the problem always manifests at the deepest layer, but the problem always is seen at the top layer. So it always starts with an user, hey, I'm not able to log in, or I'm not able to access the site, or it is slow. So what if your system learns and it knows how to categorize the ticket, even to prioritize based on historical analysis, and also assign to a set of people who have worked on that or who are identified as SMEs, but also could flag it that there is a SME who is available at that point in time, who is online, based on where he works, what is his location. Maybe you are a global enterprise, and the things happened at Pacific time, like 2 a.m., which is perfect time in London. And somebody in London sitting there just came to office. Maybe they are the right people, the right SMEs to work on it. So how do you bring that thinking into, or that kind of logic to train your system? So we have been looking at enormous amount of data for different customers, different clients, and trying to bring the sense that how do we categorize, prioritize, and assign in order to cut down the cost of escalation, war room, escalation room. Today, people spend for a P1 issue, it takes approximately like 150 minutes, and this is not my data. It's a data done by Cisco. They surveyed, and they came up with a number said 150 minutes on average, and it costs $100,000. So you can imagine, it is like that amount of money being spent because there are so many people involved in the organization and also in the customers on your consumer end in order to solve the problem, because to identification of the problem takes like 30% of the time. Then to know the problem, and then you basically start looking to fix the problem, to find who is going to fix the problem. Then you validate and push the problem back again, making sure that you have not caused other problems, right? So this is one area where AI and machine learning can play a big role in order to simplify how operation works in the future. How can IT operation move from reactive to predictive and proactive? Before we go to prescriptive, we have to become predictive. And once we are predictive IT, that means we have enough knowledge about how the system is performing, what we can automate, what we can delegate to machine, and sleep well, expecting that the machine will do the right thing, and then apply the resources where we believe it's more strategic, more value add, more analysis needed. Because at the end of the day, IT operation is no more a support of business. Technology, support of business. IT operation is the business. Technology is the business. Anyone who is not applying right technology, every organization, every enterprise, whether they're in energy, they're in healthcare, they're in retail, they're in banking, the application of technology, right application of technology will decide how that organization is competitive against their competitor. So let me say the 4 areas of innovation that digital initiative or digitization of business that is driving and the technology innovations are happening. One is contextual experience, which we talked about, being context. End users are expecting always be connected. The consumer experience they have, they're expecting the enterprise experience is the same. It's a frictionless experience. That's number one. Number two, invisible enterprise or invisible infrastructure. Your infrastructures are becoming more and more invisible. Do you know what router, what switches AWS running when you are running something in their environment? Do you even ask them? Are you running Cisco switch or Juniper switch or router? Are you running VM or KVM? I don't think you do. So invisible infrastructure is making all of us service provider. We are in an era of consumption. We consume, we pay. We don't consume, we don't pay. Third is the passive intelligence, which we are talking today, AI ops. Passive intelligence is making data as the next oil. Data is the biggest asset, is the solution and the problem. If you use the data right, you'll get a lot of answers. If you use the data wrong, I'm pretty sure you will get into a lot of problems. And the fourth is universal risk. We all say, oh, I want to be, privacy is important. At the same time, you want to be visible all the time. You want to be in Twitter and Instagram and Facebook and everywhere, wearable device, Nike shoes, measuring, how is your health. So this dilemma, how do we fix the dilemma? And how do you say that we are not in a risk environment? It is not a risk of the, cyber attack of the organization, cyber attack of the human being, the person that you are. You might be representing your organization, you might be representing yourself, but your wearable, your shoe could be at risk to breach a corporate network. So this is the world we are living in, and we believe that in order to bring this data thinking in your organization, here are the 5 steps. How do you bring data thinking holistically in your organization in order to solve the problem of IT operation? How do you make IT operation more predictable IT, proactive IT, and prescriptive IT? So the 5 steps that kind of we look at it, you start with the business. And I think digital transformation every organization is going through. If they are looking at a technology and thinking that's the digital transformation, many organizations, initially when the cloud started, they said lift and shift. They lifted their on-prem workload, went to the cloud, and they said we are digital transform. That's not digital transformation. Digital transformation, you look at what business objective you are trying to achieve and how digitization is going to help you achieve that to be more competitive against your competitor, more connected to your customer, more engaged with your employee, and more proactive in order to react to the external environments. When the external environments are changing, this policies is changing, GDPR is coming, customers, millennials are using differently, these payment systems are changing, blockchains or cryptocurrency is coming. How does it impact your business? How do you know about that? So understanding that. Everybody talked about, skills. How do you retrain? How do you make people understand how to look at data, not within their organization? I'm a SecOps guy, I only look at security data. I'm a networking guy, I only look at network data. How do I look at data holistically? Data flow. I call it data flow, not data. Like how do you look at the data flow and what data means at each stage? And apply the discrete as a tech use cases and show the value. Because if you bring technology to solve the value, you will get pushback in your organization, the adoption will get slow. So if you're looking to change, you have to look at a few use cases, show the value, eliminate, maybe the amount of time you're spending on knock, amount of time, the mean time to resolution they were spending, the amount of alert volume that your engineers are looking on a daily basis. Do not start with data. Start with business, but data will play the role because once you understand the business use case, you will start looking at it and say, okay, what data I need in order to solve this business case and how do I solve this business case? Once you have that, we are all driven by process, and sometimes our inability to execute, we blame it on process. Because process is the savior, because the process didn't work. the process between process always, people and process come as a conflict in order to get things done. And the process boundaries and process demarcation always cause a problem. So bringing the right data leadership. As you know, anybody here is a CISO? Like Chief Information Security Officer? So this is a new role created maybe in the last 5 years, right? Every organization has a CISO reporting into CIO, reporting into CEO, the security officer, because they have to look security, both physical security as well as digital security, because there is a convergence of physical security and digital security. There was a physical security who's watching, who's entering the building and things like that. All those things are gone. Everything is digitized. Same way, data has to be moved up. There has to be a chief data officer. Some organizations have already started thinking. And you can think why they are giving so much value to data analytics and how to bring the intelligence. You can see Salesforce acquired Tableau for $15-some billion. Such a high valuation they gave because they know what they can do, how they can mine the data they have in order to bring the intelligence on top of it. So it is very important to bring the data governance, data intelligence, data skills, and data leadership. Once you have that, bring the right set of data. And this is the key. This is the bread and butter, right? So what does it mean is to get kind of a data, first understand the relationship. There could be multiple sources of data, but if you don't have the context, what those sources of data mean in the context of outcome, then the source don't mean anything to me because I don't understand the destination. So building a relationship that drives what does it mean in the context of business? What does it mean in the context of service? So if you're doing an e-commerce service, if you're doing HR case management service, if you're giving a legal service, you are giving an employee satisfaction, whatever it is, how does it is supported with the technical service and how they are connected? Once you have that, let the metadata model drive and deliver the context. And once sometimes we say all data or large data is a good data. Definitely large volume of data is good, but right large volume of data, right large variety of data is good. But if you have wrong variety of data, you are basically training. It's like a kid. You are always teaching the kid the wrong thing and expecting a right outcome, right? It won't happen. So that's why it is important to bring data selection, data cleaning. So once you have the selected data, you know how to clean the data. And this is why the data science are spending a lot of time and to reduce the data so that they can transform and apply the right machine learning in order to take the right actions. How many of you here have started doing, or how many of you are data science or data scientists? Good. So you are spending a lot of time with large number of data, doing research. So sometimes it is the amount of time the data science is spending is here. They're spending time on data selection, data cleaning. Forget about applying the algorithms. They're coming later. If you ask them, maybe they're spending 70-80% time. Maybe we can talk after the session how much time they're spending on the data cleaning, selection to make sure the data model is right. Because you want to get the data right, then you can train after that with your algorithms much better and bring different algorithms, different models, because you are thinking algorithms to get more cognitions, human intelligence into that once you have figured it out, the algorithmic machine learning intelligence out there. We use quantitative data in order to identify the problem, right? The metrics, the alerts, the incidents. So all those are, the data that we understand. Then we have a qualitative data, like some logs. We have NPS score. We have the customer satisfaction, customer churn. Those are qualitative data. So while your quantitative data helps you to identify the problem, your qualitative data helps you uncover why the problem in the first place, right? Once you mix them, all the way from the perspective of business to the perspective of a PaaS service on AWS or Azure, or a resource which could be an ESX server running a bunch of VMs, or a database running Oracle or SQL Server, on-prem environment. Once you kind of connect the dots, and at the end of the day, connect the experience of your end user and a customer, you will be able to experiment and make better sense why something is happening, why the customer is thrilled, excited, happy, why the customer is unhappy, and how the sequence of time, a metrics problem, and a customer experience kind of is connected together in order to give you the signal that is needed in order to understand what the problem is all about. So that's why it is important that you apply both the data, selectively apply the data, and help understand a holistic view of what is going on in your organization. And the last one I would say, don't try to solve everything with one stroke. This is sometimes, some of the vendors say, we have a magical box. AI Ops will solve all your problems, push the data in, and voila, you will have the right answer on the other side. You can try it, and if some of you have tried, I don't know how long it took, but it is going to be hard. It is going to be, time-consuming. You may get the result at the end, provided there is a patience and everybody in your organization is okay with that, to spending amount of money and the time needed. What we have found working with our customer, that you take, set of tasks, you eliminate those tasks through machine learning, which is kind of repetitive tasks, high value, and have limited human interaction. For example, in some cases, you can automate some things based on your past experience. That, hey, it's always a restart, or it's always a config change, or it's an update, or verify that, or basically notify this team, or assign the tickets there. And we showed you a bunch of use cases. You can apply those use cases based on graph, based on statistical model, computational model, based on algorithm that you have, and you solve that problem. Once you saw the success breeds success. So I always say, think big. You should have a strategy in place, what your business wants to solve the problem of IT operation in next 12, 18, 24 months, and then act small, but once you have the success, move fast in order to kind of bring that learning across the different use cases that you have in your organization to really drive operation management from reactive to proactive and predictive. We believe the DevOps and IT Ops will converge. Even though they look like two different organizations today, they will converge. And AI Ops will play a big role in converging the DevOps and IT Ops, because people will see how the data is flowing between them. It is not that development and operation. We need the skills of both and expertise of both in order to really make this next generation predictive IT fully operational in a hybrid cloud environment. With that, the last and I talked about it already, data can help create better understanding between different organizations of IT operations, whether you are security, application, infrastructure, network, storage, cloud, non-cloud. It will bring the transparency, collaboration, and productivity, because once you have the right data, data doesn't lie. Data will make sure that people understand, because you have created a data-driven organization, a data flow organization, not just a process flow organization. That will help to bring change faster. You don't have to have a CAB meeting with 16 people to decide why this change should go on a Friday night, because people will be able to see the impact of the change, which are the process is changing, what is impact happening, which end users are getting impacted, which organization is getting impacted, and what is our, if things go wrong, how can we roll back? So they will understand the change. So that means the speed and quality of change will improve significantly, because when there is an outage, interruptions or some breach, it is mostly a change. It's mostly a human, right? So the DevOps, you will be able to adopt, and you will be able to apply the agile operation that some organizations are failing. A 20 people startup, everything is DevOps. When you are a 5 people organization, 500 people organization distributed across 6 different countries, 6 different geography, DevOps are becoming challenging, right? So how do you do that? This data-driven context will help that. And at the end, you will be able to minimize risk and also optimize the cost. You will see where you are spending time, what cloud resources you are using, what cloud resources you can scale down, who is using at what point in time, and why they are using only at the end of the month and not at the first 3 weeks of the month, and that will help to solve the problem. So with that, I know I kind of went pretty fast because of the time and the things that I had to cover, but thank you for staying. I know it's late in the afternoon, and for some of the folks from East Coast, it's pretty late, dinner time. So if you are interested, we have a booth, 409, here, so you can stop by, look at a demo of the product that we have, and here is my contact information. I think I have only 14 seconds, so maybe I'll take question outside, and thank you. Thanks, everyone.
Bhanu, thank you very much. Yeah, please feel free to approach them with any questions you have. And so, go forth and conquer. We're going to be back here at 5:20 with a panel about blockchain, and we've got some really interesting panel members. We're going to come at it from sort of a real conservative, business-oriented way to a Wild West crypto way. So it should be a lot of fun.